Hello everybody, my name is Cousin, and I'm going to be showing you my new Robotics program editor and autonomous programming tool. So right now this is the alpha version, and all I have set up is a basic project helper tool, project helper, yeah, my bad, project helper tool that'll help set up odometry on robots much quicker than you could normally do in Vex Studio. So let's go ahead and load up a new robot object. So this is all custom built in Python, based in Pygame. So we can just go ahead and set up a robot called test. We need to find the width, so just call it 10 inches by 10 inches. And then in the editor, you can set up a tank drive on X drive. We'll go ahead and set up a tank drive. So in this area right here, we can set up all the motors. So we can set up motor A, call it on port 1, submit it. On port B, we can have it be on port 4. We can reverse it if needed. We can also set the stopping mode to coast and set the 6 to 1. Submit it. Also add a C motor and a D motor. So there we go. And then on the drive base, we can go ahead and add our motors to each of the 4 possible segments on an X drive. We could also switch this to a tank drive and just add A or B. But we'll go back to the X drive and just reset it up real quick. This is also set up so you can have multiple motors on each one, so it will scale appropriately. We can also add some sensors or add an inertial. You can select the type right here, port number. And then we can also set up all rear based encoders. And when we update that, it will also change the port options. So we'll add a left one, and a horizontal one. You could also see the other types of sensors that we have currently set up. Not as much as Vex in its native one does, but you get more options from Vex, but here it's all integrated. So coming back over to our drivetrain, of our inertial sensors we only have one, so we can select that for our drive base type. We can set up a right encoder, and a left encoder, and a horizontal encoder. And what this will do is when it creates our tracking function when we're ready, it will export all that and set up the appropriate tracking function. So I can show you that right now. Since we have a robot configured, we get these lovely options. If something is not exactly right, we don't get these options. Okay, set it back to 10.0. And then in drive base, these are all the odometry or PID control variables you can add. We'll just go ahead. I'll show those later. So in the future, I plan to add an autonomous editor, which allows you to interact with a field and plan your autonomous paths in this program. You also have a driver editor, where you can interact with the controller and determine what each button does, and have a code editor, where you can create snippets in this window and then connect it to driver or auton stuff. You also have a save and load feature, so we can go ahead and save this test robot. When we come back over here, we can come load this robot or the alpha robot, and everything will still remain set up. I have a slightly different configuration, but all these drive base variables are remembered, so you don't have to set up a new one every time. And this helps because you don't have to update all these variables in the Vex editor, which can be a hassle because you're jumping around header files. And especially when we get into exporting these drive tank options, I've already created it, so all these options are included. So we can go ahead and export this file, and we can check exports, and it sets up the entire Vex code project. So we have a robot.v5 code here. We can go ahead and open that up, and the entire project alpha RB1 generated template, all that is set up for us. So you can go ahead, open it up in a standard Vex Code Pro editor when all this is exported. In the implementation, so this is the exported stuff, it will go ahead, set us up on the left encoder, right encoder, and it'll set up a tracking function for a robot that will track its location using the inertial sensor in right and left encoders. If for some reason we didn't have the inertial sensor, it will use the right and left encoders to adjust itself. So let's say we had a encoder width of 10, we can export it, come over here, it updates this file for us. So instead of tracking the heading via an inertial sensor, it'll go ahead and use the tracking wheels to calculate everything for us. And let's just say for some reason we didn't have all the tracking wheels we need. That's no problem, because even so, we can export it. It will use our standard drive wheels and calculate it based on our heading. It will calculate our change in position vector, also based on the drive wheels, if we don't have encoders. And this also all works if we were in a tank drive configuration. It would change the math a little bit. So this helps a lot when, especially in Vex code, you don't have to change all these as your robot changes. And when you're trying to change motors, you don't get those annoying chain comments at the top of your file. It'll also go ahead and add all our sensors and motors in these groups right here for us, so we don't have to worry about it. Robot functions, if we don't have the right encoder anymore, it goes ahead and removes that. But for whatever reason, in your autonomous planning, you still need a left and horizontal encoder. It'll go ahead and create those functions for you. So this is just the alpha project. Nothing too fancy yet. I've made it auto-include my odometry files. So if I wanted to pull from my odometry library, I can. If I want to change what odometry library it's using, I can just open up this template over here and change what kind of heading files, because it all compiles based on this template. These are the tracking functions I was talking about earlier. So you can quickly code something up in the template and drag and drop in your robot variables set up in the editor, and you're on your way.